What an incredible discussion. That was so fabulous. As a biologist myself, I thought that was incredibly inspiring. And we're going to dive into the world of entrepreneurship and big data. And I have to say, I'm particularly excited about participating in this and the fact that Margot invited me. My son actually graduated last spring with his master's from ICME in computational math. And it has opened up his mind and the number of opportunities. So thank you, Margot. Great. So we have this fabulous panel. Why don't we go through and everyone give a quick introduction to themselves, just a couple of sentences, and how you're using data science right now.
I'll start.
Yeah.
I'm Monica Rogati. My background is in applied machine learning. And what I'm doing right now is I'm an independent data science advisor. And previously, I was the VP of data at Jawbone in the wearable space. I built and led the data team there, building data products and data stories. And before that, I was at LinkedIn, building recommender systems and finding more interesting patterns in the data.
Great.
Hi, I'm Jaya Kolhatkar, and I come from Walmart Labs. I manage the data and analytics infrastructure at Walmart Labs. Part of my job is to have a team that builds predictive analytics for transactional systems. But the core of my job is to create a data platform and analytics tools that allow our data scientists in the various areas of the business be more productive and add more value into the business itself. I came to Walmart Labs about 2.5 years ago when my company, which I had co-founded in 2011, was acquired by Walmart Labs. And I've always been in predictive analytics for most of my career.
Hi, Tina, and thank you for having me in this panel. My name is Helena, Deus.
Can everybody hear? Because it doesn't seem very loud. Maybe we can turn up the gain. Thank you. Thanks, Lincoln.
I work for a company called Foundation Medicine, and we're in the business of applying these discoveries that Jennifer just talked to you about in personalized medicine. So at Foundation Medicine, what we do is we help oncologists by giving them the most accurate, or what we try to be, the most accurate information that they can get to treat their patients. So data science pretty much permeates everything we do. The sample comes in through the door, we sequence the cancer genome, we compare it against the normal genome, and based on that information, we identify which mutations are driving the cancer. So as Jennifer pointed out, not every gene is driving the cancer. Certain mutations are there because the DNA repair mechanisms are messed up, and so the cell is not able to fix itself. At Foundation Medicine, once we see those mutations show up in the patient's genome, we then hit the papers, we find all relevant literature, all relevant drugs that are applicable for those particular mutations, and we send that information back to the oncologist so that they can make the most informed decision they can make.
Great. So we're going to dive into this more deeply. So let's just finish our introductions. Great. Thank you.
Hi, I'm Montse Medina. I'm a co-founder at Jetlore. Jetlore works providing product discovery to e-commerce companies. So if you are an online shopper, most likely you have been exposed to our algorithms. And I'm actually one of the two original developers of the Jetlore algorithms.
Great. So this is a wonderfully diverse group of people. I want to craft this panel right now in real time that we're going to pretend we're at a very lively dinner party. Okay? Imagine you've got a glass of wine in front of you and there's no one here listening, okay? So it would be great to have a discussion about where you see the world and the opportunities with data science in your different disciplines are going. Because this is an area with constant change, really brand new tools, new ways of approaching. Where do you see the future spreading out in your different areas? And anyone, jump on in.
I'd say the biggest issue right now is how to measure data quality.
How to measure?
Data quality.
Data quality.
So data is coming from all over the place. All sorts of databases have data. And we are not just don't know how to measure the quality of the data. That ends up being a major bottleneck for any data science initiative. Because if your insights that you can get from any data science project are only as good as the data that you put in.
Right, garbage in, garbage out.
That's
so
right.
you need to make sure you've got, so how do you deal with that? How do folks deal with making sure you've got good, clean data?
So you really can't say at the outset whether it's good, clean data. And you always have to look at good, clean data in the context of what you want to do. So we try and figure out how we can robustly test very quickly the quality of data. We know what we want to do with it a priori, hopefully. And then we can then start testing it and attaching value as we understand how it helps influence the decisions that we want to make and create a value system for the data that we're bringing in, and then leverage it in other algorithms as we go along. So we've been using more testing.
And you have to be a detective, right? So I encourage data scientists to really take a look at the individual data points and understand how they fit together and really explore the data in depth and be very, very skeptical of what's coming in. And that's something that in academia we don't deal with as much. We have clean data being served to us, but then when you go out in the industry and you see how dirty the data is coming in, you have to really be skeptical of it and be a detective. And it's a really interesting and challenging problem in itself.
Yeah.
Great.
Actually, I totally agree. I was just going to say exactly the same thing. The way we describe data scientists at Jetlore is data detectives. There's different kind of people that may know some algorithms or others, but ultimately what you want is that person that can differentiate the noise from the signal. And that is what we call a data detective.
Great. So what other, besides concern about clean data, what are the opportunities you see going forward as you're looking ahead?
I think one of the biggest opportunities is around making things smart, right? So that's the broad category of data products. So we're surrounded by products, and what we want is for everything to be smart and adapt to us and so on. And data is a big part of that. How do you personalize your experience? How do you make it more effective, even from medicine to education? How do you make it more effective? How do you put together these smart products? And if you do it right, a lot of the data is invisible, and the interfaces are invisible. So the really big opportunity around data products is around making them smart and personalized.
Great.
The things that we are looking at is we're looking at data that is not truly connected together. If I wanted to say, how is someone, the way they interact on Facebook, how do they actually shop? It's not directly connected. So how do you do this inferential connection that allows you to create some value and allows you to understand how a person wants their experience to be personalized? So that's something that we are working to figure out.
And that's an excellent point, because that is what you find on the web nowadays, right? And even though it's there, it really isn't connected. There's no connections between data in PubMed or data in databases that publish that information. So the connectivity of the data, ways to increase that connectivity, whether it's inside a company or across public data sets, that's really, really a key point. Great.
No, I'm the last one. Everything has been said.
Okay, great. Super. Well, as somewhat of an observer of this field, it's clear that there are lots of online or available tools that you can use that other people have developed. And then there are things you develop yourself that are proprietary. Do you find, especially in an entrepreneurial setting, that there's a tension between using tools that have already been created by other people and then creating proprietary tools that are going to allow you to do things that other people haven't? So can you talk about that, sort of using off-the-shelf tools versus creating them yourself?
So we build everything in-house at Jetlore, and one of the reasons is because what's out there does not scale at the level that we need to scale. We are powering the recommendations of product discovery for top online companies in the world. So obviously the scale, whatever tools you would find would not work. So everything that we do has to be in-house.
Right. I'd say that there's also the risk that we need to minimize. So for example, I mean, we're a rather medium to large company nowadays, and you don't want to go with MySQL for building your databases. There's plenty of problems there. There's no company behind it that could provide you customer support. You want to use Oracle. You want to use something that's robust and tested, et cetera. So the decision really relies on how much risk are you willing to take. Is it a research project? Is it something that you need to customize? In that case, we go with products that we build ourselves. But if it's something that you really need to be up to date, robust, et cetera, secure, then it's preferable if you buy a tool.
But preferable to buy it.
Yes, if you need something that's robust.
Yeah,
Because someone else has already tried it and tested it, and you know that there's already market for it.
and support.
So I think you've got to really look at the balance of what you want to build versus buy. Buy things that are, standard. Everybody uses them. There's no real victory in reinventing the wheel. But then where things are very, very specific to your business, build everything in-house, because that gives you competitive advantage that you would not get with standard products that you might buy.
Great, and I guess then control over what things you can tweak.
Yes.
Great.
I've seen both sides of that argument. On the one hand, at LinkedIn, early on in the LinkedIn data evolution, we had to build a lot of things in-house because they just weren't there. The scale, to your point, you couldn't get something that scaled as fast as we needed to for data product at LinkedIn. So that's how a lot of products that then were open sourced and perfected and that are now available to use to everybody here, products like Kafka that a lot of people are using here, Voldemort, and so on. There's a lot of different technology that has been developed in-house to address that need to scale. And then now it's available for everybody to use, in which case you should take advantage of those years of development, and it's a good idea to use it and adapt it to your own purposes.
Interesting. I'm going to guess you've got all this data coming in. There's a lot of questions about what questions you ask the data, right? And there's a lot of strategy that goes into determining how you're going to be looking, what lens you're going to use to look at this data. Who makes those decisions? I mean, if you just ask the data scientist, they might not have the business perspective. If you ask the business person, they might not have the understanding of what actually can be extracted from that data. Can you talk a little bit about that decisions about how you actually query these large data sets?
That goes back to the definition of the data scientist, interestingly. A data scientist is, or the unicorn data scientist, which is why it's so hard to find, is somebody who has a combination of the business knowledge, combination of statistical knowledge, and a combination of computer science knowledge. And you rarely find all of those three in one person. So in my opinion, the best way to make those decisions is to actually get in a room all the people who have the combination of those skills and brainstorm what is the next direction that the data scientists should take.
Well, at a startup, actually, when you are quite small, you do get people that are working for you because they are genuinely excited, especially in such a heated up market for data scientists, right? They would work for you because, well, they want to work with smart people, but they also are excited about the impact, and then they care about the business. So generally, they are interested in knowing, well, what's the most important thing? The most important thing is to increase revenue for our customers. So then what are the most important problems to work on? And generally, everything aligns.
So at Walmart Labs, I think we have a very strong business team that has spent a lot of time understanding what data science can do for them. And you're going to hear from Kelly this afternoon regarding how she has thought about data science in the context of how to grow the business. So we leverage both these parties very heavily, working together to say, what is it that we're trying to solve? Many times the business team won't know what data is available for us to solve that. So the data scientists bring, what availability of data is there, what algorithms can be leveraged to build algorithms for solving a particular problem, and the business team brings in the necessity, the value of what these algorithms can do for the business. So it's a great combination.
What I advise data scientists to do is to think about the impact before they even start asking a question or working on a problem. There's a product development strategy that says you should write a press release first when you're trying to develop a product, right? And similarly in data science, you could think through, before you even start working on it, what's the best case? If I work on this, what's going to happen? What's the result that I'm going to see out there? What's the likely case? And what's the worst case, right? So once you see those three, you can think about and how much effort, estimate how much effort it's going to take, right? So thinking of ROI, where R is not just money, but everything good divided by everything bad. And so thinking about the impact it is really helpful because you get to imagine yourself having built what you just think, or having answered the question that you just thought about, and then evaluate the impact once that question is answered.
I love this new definition of ROI, is everything good divided by everything bad. So can you give any examples of a place where there was a really interesting marriage between the business folks who were asking a probing question and the data, or where the data scientist informed the strategy folks about, wow, if we look at the data this way, we're going to get some really interesting insights? I mean, I'm curious, is there any particular example that bubbles to the top that you go, wow, this was a really interesting insight that came from looking at something from a very unique perspective?
Well, in our case, typically those insights come from R&D. We, as part of our operations, we sequence many samples per day. And sometimes scientists would notice, oh, this gene, it's not reported in the literature for this cancer. Let's see if we can find it in other samples. And so that often drives the improvements of the test. So the business will then decide to put that gene and to put more emphasis on testing for a particular feature.
Great, just like we heard in the previous talk, like you go, well, there's something here, and we haven't been looking at it. Maybe we need to turn our light to look at and see where it's
That's right.
relevant. Anyone else have an example?
I have something. An example from Jawbone, and Jawbone is an activity tracker. And so one thing that we could do, and we have studied in the data science team, is to what extent the weather, and that's relevant because it's pouring out, to what extent weather affects your activity levels. Mm-hmm. So we looked into that, and we published a blog post which you can check out. But the insight there was that weather does affect your activity level, only on the weekends or outside of the working hours. And well, that sounds kind of intuitive, right? But we were able to measure exactly how much of an effect there was, how much people are responsive to the weather, and how much their activity changed. Now, the reason that's useful is because this is a natural experiment where you have some input and people respond, right? So you can imagine if we encourage people to move, right? You have to be careful when you do it, because if you do it on the weekends when people are open to being influenced, then you're going to have better results than if you do it when people are not open to being influenced. When Mother Nature couldn't get you moving, what chance do a little phone notification has, right? So that's an example of where some data science insight informs actual product decisions that make the product better.
Great. I want to let people in the audience know that we are going to open it up to questions from the audience in a few minutes. So you can put your thinking cap on of the most probing questions you can ask these wonderful panelists. So here we are at this university where people are learning a lot about data science. Let's flash back to when you were in school. What type of things do you wish you had learned? What skills, what knowledge that would have helped you at this point, and what sort of guidance would you have for the people who are still in school who are thinking about a career in this discipline?
So I'm not too far from that, right? I left not too long ago, but there's nothing that I actually regret, because I was lucky enough to have people that really pushed me into where I was not comfortable. So I actually had an advisor that really pushed me to learn very strong fundamentals in programming, and my co-founder with whom I was working also from the Stanford days, he also pushed me. I really think that this is one of the skill sets for us. The most important thing is, can the person think clearly and have strong foundation in the very basic things? What is the core of an algorithm? Why does it work in this setting? Can I take the insights of why it worked here and put them into a different setting. That would be the fundamental, and clarity of thinking. And then the second thing is, can the person implement this so that I don't need another engineer to actually test the hypothesis? So if the person has these two skill sets, I can basically teach the person anything. And that is the core thing. I do not regret, because I actually had people that pushed me into that route that made me very uncomfortable during a couple of years at Stanford, taking a lot of classes that may have not been optimal for that moment, but definitely went a long way.
Great. I totally agree. I mean, there's so many women that shy away from programming classes and math classes. No, just take those classes. Push yourself out of your comfort zone. Because, I mean, in tomorrow's world, not knowing how to write code is like not knowing how to write. You know, we all need a little bit of scripting skills, just the beginnings, because the rest we can learn by ourselves. Yeah. But taking classes and those core fundamentals of programming and computer science is so critical.
Do you think it's also important to layer in the business skills? You mentioned that having people who could both speak the language of business and strategy as well as the language of analytics, that's a really powerful. Do you think that each person should have that, or is it just that collectively as a team?
Well, I think that this is something that you grow into. So there's people that are interested in that, and there's people that are not so interested on the business side. So it's very hard to get a job and automatically be at that position of power where you can make business decisions as a data scientist. So generally, you grow into that. It's more important to be able to prove yourself within the organization and then decide, do I want to take more of a business route and lead a team, or do I want to be a data scientist per se and just dedicate myself to data science?
Though I would suggest that, you know, everyone who is hoping to work in industry with a data science background should think about having some knowledge of, you know, what strategy means, how people develop products. These are core essential ideas that, you know, can help you develop your, you know, your value to the business in a much greater sense. So I would definitely suggest some level of understanding of business and data science interaction.
And I think to that question, I think that goes to impact, and you can evaluate impact from a business perspective, and you can evaluate impact from in academia, right? So you can think about, okay, if I have an idea for a paper, what if I do write it? What's going to happen? What can I do with it, right? So that kind of thinking, developing that kind of thinking early on and being grounded, it transfers very easily from academia to industry, but you have to develop it. In the first place. And the other, we could have a whole panel about what we can teach in academia to make it better. But one, I hinted at having dirty data and having hands-on projects that are not, that don't have clean data coming in, right? That's really important because you learn how to deal with that. And that's something that I see new grads lacking a little bit. And similarly, I see new grads being given a data set and assuming that you have to restrict yourself to that, and going anywhere outside of that is cheating. When in industry is everything but. You do want you want to think creatively about the extra signals you can pull in. Because that's key to getting your performance better. It's not necessarily about making the algorithm better, because that might give you a 5 or 10%. Getting a new signal in, that's a 50% improvement, right? So you have to think like that instead of thinking like, oh no, I have to restrict myself to what I've been given. So that's something that we can do a better job teaching early on in academia.
I love the idea that creative problem solving is core here. I also know that one of the things at Stanford that a lot of students do is do a combination of the technical skills and then also take classes in our department, like management science and engineering. So they're essentially, we talk often about T-shaped people, those folks who have the depth of knowledge in a discipline, but the breadth of knowledge across, you know, other important skills like business and strategy that helps them. So I love seeing this discussion. You come from different types of environments, whether big companies, startups. Do you think that one approaches these big data analytic problems differently if you're in a big company with a different type of organization and goals than you do in a small company? Or do you say, listen, it doesn't really matter if I go to a big company or a small company, it's all the same? Do you see differences in those environments?
Oh, for sure, yeah.
Yeah, so what are the differences?
The data is much bigger in a big company. There's so much more data. It's so spread out. Data governance becomes a really critical issue.
Data governance?
Right.
Wow, that's a new term. What does that mean?
Well, the ability to know what data you have, where it is, and what it means.
Interesting. So what you're saying is that big organizations have much more data available. Is that really true?
Yep.
Not true in our case.
In general, so a bigger company, you have more data to work with.
They have more data.
Okay.
Not true in our case, actually, since we collect the data from all of those big companies, so and collect all of that. So we actually
You're actually fixing the data governance problem.
So we actually have more data than any single big company individually. But in our case, the difference would be that I guess that for us, we have to be a little scrappy. We have limited budget. If we do not meet our goals within a week, I would say, you come up with an algorithm, you just implement, you launch it. Look, how did it affect the revenue of our customers? Undo or fixed. But you have to be very scrappy. You have to test with, you have to build a minimum viable product very, very fast. We do not have limited resources. We do not have a team of 60 people working on the problem. It's just a really, really small team. Work fast, deploy, and see how it works. And we don't have another thing that is the external competition, because we do have a lot more external competition. When you have an internal data science team, you're fighting against nobody yourself. You may have some artificial goals for the company, but for us, the goals is we do have to be better than anything out there. So that is our goal. Otherwise, the company would not succeed.
Any other perspective on that?
So one of the things that I do agree, being in a smaller company, you have to be scrappier. You have to figure out how to move really fast. Some of the things that we've tried to do is we say to to the world that we are a startup within a really, really large company. And we try and create infrastructure that allows our data scientists to behave like being in a startup. They are empowered to build things fast, deploy things fast. The one thing that is great about being in a big company is even if you make the tiniest bit of change, the impact that you have from a dollar perspective is so tremendous. And it goes beyond the dollars, right? Walmart serves roughly about 250 million customers every single week. You make a change to make their lives better, that's 250 million people that you're touching. So it has huge impact beyond dollars as well. So that's kind of what we empower our data scientists to think about and live in this environment and try and make these rapid iterations.
Did you want to add something?
Yeah, I agree with that. I think at small companies and at startups, the speed of experimentation, which is crucial to data science and data science development, is higher. But as a big company, if you want to stay on top of your game, you have to make sure that your speed of experimentation is comparable.
Great. Let me open it up. Who has a burning question? Yes, please say it really loud. Oh, and there's a microphone coming this way. Maybe. One way.
What is your experience managing groups of researchers along with business needs? Because like a lot of people come in from academia and their approach is very different from what the industry demands, and you want to keep them innovating, but at the same time you do not want to stifle them. Given that you're all like directors of data science and such like titles, I would really like your perspective on this.
So we spend a lot of time bringing in new talent right out of school to help us build very strong data science teams. And it is actually quite quite hard to balance, making sure that someone's creativity is not stifled versus making sure that they understand what they're building has huge impact, and how do you do that? One of the things I typically tell my, my data scientists is that they really need to, relax a little bit, because we have a lot of data. We also are making incremental changes. We are not curing cancer. So they need to know that. And as they think about their algorithms, it's OK to take some chances. It's OK to be a little bit more generic rather than be more specific. Be slightly less accurate, it's OK. So getting them to go from being very, very accurate, the results tying up, to having a slightly more relaxed attitude sometimes is helpful for them to fit in.
Great. Another question.
Yeah, hi. Yeah, my question is, where do you sit on the spectrum on your data philosophy from one extreme being capture all the data you can, grab all the data you can, so that in the future, if you think of ideas of what to do with that data, you've got the data, it might be super messy, versus something that's totally opposite, where you would carefully plan and intentionally capture only or specifically the data that you would want for purposes you know of now?
I'll take a shot at that. I'm on the side of capturing as much data as possible, obviously within making sure that the people's privacy settings and so on are right. So, and storage is cheap. So capturing as much data as possible early on, and even brainstorming with your data science team, what kind of data are you missing? What kind of data are you not capturing? Is really important, because later on you could develop new products, and I have seen some controversy on Twitter and so on around, no, you should first have a good question and then gather the data to answer it, which sounds very logical, except the example that I gave was, CEO coming to you and asking you, hey, is our business dying, or is this a seasonal effect? And you say, I'm right on that, Gil, I'll get back to you in a year. Doesn't quite work, right? So I'm on the side of capturing as much data as possible.
Okay, another question. Over here, table 21.
How do you handle the relationship with infrastructure? You have to compute somewhere, and you have to collect those data and do something about it. Could you try to describe how you manage that?
Be really nice to the IT department. They hold the keys.
Other than alcohol bribes, one thing that I've done when I built my own team, I wanted to have half data scientists, half data engineers on my team, just so they are working towards a common goal. So that's one hack that I imagine.
You want to add some data engineers, who are the ones that are going to build the scalable infrastructure for the data scientists. Generally, they are computer scientists. They have some interest in algorithms, but they are not a data scientist per se. So, but they would understand the algorithms, and they would be able to implement the algorithms at a large scale.
So we try to do that as well. I think that helps having a mix of both data scientists and engineers. We throw in product managers as well from a scaling perspective, and the three together tend to help us get over some of the hurdles of the infrastructure.
Great.
Helena, I'm Intel Labs. I'm computer architect and memory architect, so hence the question. You talked about challenges in collecting data and accessing to the clean data versus dirty data, and also the tool set. So my question is that, how far are we from the computation and memory resources? What would be on your list, on your wish list to buy the infrastructure, the computation, and the resources to do all these data science algorithms? Are we very far from there, or the kind of resources that we have today you think will address the challenges that we have in computation?
So we actually, we do obviously an offline training, and we do a cleaning of the data offline, but all of our algorithms run in memory online in real time. So we do not have any kind of pre-computed algorithms. So everything runs in real time as the user comes in that moment. We would run the algorithm for that user. But obviously, there is the pre-cleaning process of the data and storage of the data and preparing the data. And then there is a stage of offline training to make sure that the algorithm is going to perform.
Great. Another question? Do I see one? Over here, great.
Hi, so considering that all of you are from different departments, how often do you seek out other industries to solve problems in your own, in your sphere of work? So like earlier, Jennifer was speaking about neurosciences, and I am actually from a networking department, and I'm looking at that. I'm thinking maybe solutions that we've formed in terms of like maybe dynamic routing protocols that can probably help in other fields. So how often do you seek that out, and how do you define that structure? Which all departments you need to look at, and how that can actually benefit yours, if at all?
Being in a really large company is very helpful that, when we build our data science teams, we don't restrict ourselves to a certain area. Listening to Jennifer's talk today, I was sitting there and I'm like, we could use that there. We could use that in some other area. You want to be able to have people with very different perspectives and industries that they have perhaps worked in or studied in, to come in and have a different perspective on how one can solve any given problem.
Actually, it's actually better because you may bring what I was talking about, the foundation, right? Understanding the fundamentals of algorithms. You may have somebody from another field that has been using certain algorithms, and all of a sudden they can just apply it to your problem, and you would have never even thought about that. So it's actually beneficial. The only concern that we have generally when this happens is that when somebody comes from a very different field, generally they're very passionate, and it happens a lot when it comes from when they come from biology, or when they're in the medicine field. Generally, they're extremely passionate about the cause, and it's very hard for them to get excited about another kind of problem. But that would be the only inconvenience, I would say. If the person can actually get over that and get excited about the problem you're solving, then it's only beneficial.
So I want to just end with everyone just making a closing statement about where you see the biggest challenges / opportunities. I'm a huge believer that problems are opportunities, and the bigger the problem, the bigger the opportunity. So where do you, it could be in hiring and getting the right people in. It could be some technical issue. It could be some, whatever it is. What do you see as the biggest sort of problem / opportunity right now for you?
I'll start with thinking about sensors and thinking about how we now have more and more data flowing in from sensors all over the world and all around us, and thinking about how to process that data and to understand it and how to use it to make better experience for people and to find interesting insights and interesting patterns. I think that's a huge opportunity, and that's developing, and it's going to grow by a lot in the near future.
Great.
So one of the worries that I have is there is so much data that is available and coming in. I worry that we would get caught in this whole net of all of this data and how to leverage it and get caught up in it and not really be focused. So sometimes I worry that we have too much data.
We're drowning in
data. We might drown. So how do you make sure that you keep yourself grounded?
Yeah, I'd say I'd reflect the same sentiment. How do you separate the noise from the signal? But also it's worth recognizing that we live in a unique area for data sharing. People are sharing their data everywhere. And there's actually some pretty powerful insights that we can derive off of that. Things that people have never thought about before could actually be very useful when we just pull it from Twitter or Facebook or LinkedIn.
Great.
I'd say that's a great opportunity there.
Well, they took my point, so I'm going to give another one. But so I guess that from a bias perspective, coming from my space, I think that the marketing automation is really going to be big in the next years. And just because it's been in the infancy, everything that was done many, many years ago, and it's just been built upon very simple strategies. And I think that it's ripe for a disruption. It's ripe for new algorithms coming in and applying it to many other fields within the marketing automation.
Well, this was totally fascinating. I know the room is filled with lots and lots of really fascinating people with different backgrounds. As we go into the break, I invite you, encourage you to meet as many people as possible. The connections are going to be incredibly rich. Please join me in thanking this incredible panel.